You eat chicken, you eat beef. You eat lamb, fish, shrimp, turkey, duck. You eat animals that eat grass, animals that eat grain, animals that eat other fish. But here's something you have probably never once thought about. You do not eat lions, you do not eat wolves. You do not eat eagles or sharks or tigers or bears. Nobody serves predator meat at a restaurant. Nobody sells it at a grocery store. Nobody is out here grilling up a nice medium-rare lion steak on a Saturday afternoon. Why not? It seems like a simple question. It seems like it should have a simple answer. But the real answer goes so much deeper than you expect. It goes into evolutionary biology, into toxicology, into the food chain itself, into the chemistry of muscle tissue, and into a series of facts about predator bodies that will make you genuinely uncomfortable the next time you look at a house cat. This is the story of why we don't eat predators, and it is a much stranger story than you think. Let's start with the most obvious answer, the one everyone gives first. Predators are dangerous. You can't just walk up to a lion and stab it. Fair point, true point. But here's the problem with that answer. Humans have been hunting dangerous animals for hundreds of thousands of years. We hunted mammoths, we hunted cave bears, we hunted giant ground sloths and aurochs and wild boar and hippos and every other creature that could kill a human being without much effort. Danger has never stopped us from hunting something. If anything, danger made the hunt more prestigious. So danger alone doesn't explain why predators ended up off the menu. The real reasons are deeper, more interesting, and more biological than you'd ever guess. Let's start with the food chain, and specifically with something called biomagnification. You've probably heard the phrase, "you are what you eat." It turns out, in a very literal chemical sense, that is exactly true. And for predators, what they eat creates a serious problem. Here's how it works. Toxins, heavy metals, certain chemicals, certain compounds the body cannot break down accumulate in tissue. When a small fish absorbs a tiny amount of mercury from the water, that mercury stays in its body. When a bigger fish eats 100 small fish, it absorbs 100 times that mercury. When an even bigger fish eats 10 of those bigger fish, the mercury concentration increases again. Every step up the food chain, the toxic load multiplies. This is called biomagnification, and it is why we already warn pregnant women not to eat too much tuna. Tuna is a predator. It sits high on the food chain. Its mercury levels are significantly higher than the small fish it eats. Now scale that up to a terrestrial apex predator. A lion, a wolf, a tiger. These animals have spent their entire lives eating other animals. Animals that ate other animals. Animals that absorbed every toxin, every heavy metal, every accumulated chemical from everything below them in the food chain. A lion's body is essentially a concentration device for every problematic compound in its ecosystem. Its liver, the organ responsible for processing toxins, contains some of the highest concentrations of toxic compounds of any animal in its environment. Eating a lion's liver would be genuinely dangerous, not hypothetically dangerous, actually dangerous. And it's not just heavy metals. Predator meat carries a much higher parasite load than prey animal meat. Animals that eat other animals are exposed to a much wider variety of parasites than animals that eat plants. Every prey animal a predator consumes potentially introduces new parasites into its system. Tapeworms, Toxoplasma, Trichinella, various forms of flukes and roundworms that spend parts of their life cycle in prey animals and parts in predators. The parasite ecosystem inside an apex predator is extraordinarily complex and extremely hazardous to anything that eats the predator, including us. This is actually one of the reasons cooking meat was such a revolutionary development in human history. Heat kills most parasites, but even cooking cannot neutralize every compound that has biomagnified up a food chain over a predator's lifetime. Some of those compounds are heat stable. They survive cooking. They end up in you, soft CTA, 500 words asterisk. If this is already breaking your brain, subscribe, because we go this deep on every single video. Ancient history, human biology, the questions nobody thinks to ask, every week. You don't want to miss what's coming next, but here's where it gets even more interesting, because the toxin problem is only part of the story. There's a second reason predator meat is largely avoided that has nothing to do with toxins at all. It tastes terrible, not subjectively terrible. Not some people don't like it, terrible. Chemically, structurally, fundamentally terrible in a way that is directly connected to how predators use their bodies. Here's the biology. The flavor of meat comes primarily from a combination of fat content, muscle fiber type, and the chemical compounds that develop in tissue over the animal's lifetime. Prey animals, cows, chickens, deer, lamb, have muscles used for sustained movement, grazing, walking, running. These are muscles rich in slow-twitch fibers and intramuscular fat. That fat is where most of the flavor comes from. It is also where most of the pleasant texture comes from. When you bite into a well-marbled steak, what you're experiencing is fat and the muscle fiber melting under heat and releasing flavor compounds. The diet and lifestyle of the animal directly determines the quality of its meat. Predators use their muscles completely differently. They are built for explosive, short-duration, high-intensity activity. Sprinting, pouncing, fighting. These activities use fast-twitch muscle fibers. Fast-twitch fibers are dense, lean, and low in intramuscular fat. They are also high in myoglobin, the protein that carries oxygen in muscle tissue and gives red meat its color. High myoglobin content combined with low fat content creates meat that is extremely tough, extremely gamey, and extremely unpleasant to eat. Multiple historical accounts of people who have eaten predator meat describe it as stringy, foul-smelling, deeply unpleasant, and almost impossible to make palatable regardless of how it's prepared. There are recorded historical cases of humans eating predator meat during famines or extreme survival situations. Accounts from early explorers in Africa describe eating lion and finding it almost inedible, described variously as rank, oily, intensely gamey, and deeply unpleasant. Some accounts of people eating wolf describe a similar profile: strong, almost chemical smell, tough, stringy texture, flavor compounds that persist unpleasantly regardless of cooking method or seasoning. The fat that does exist in predator tissue tends to be concentrated in specific areas rather than distributed through the muscle. And it has a composition high in certain fatty acids that produces a rancid, unpleasant flavor when cooked. Your ancient ancestors tried eating predators. They almost certainly did in lean times when there was nothing else. And they very likely concluded, based on direct experience, that it was not worth it, that the toxin risk was real, that the taste was bad. That the effort of hunting something actively trying to kill you, only to end up with meat that made you sick and tasted terrible, was not a trade-off worth making. And over hundreds of thousands of years, that conclusion embedded itself so deeply in human food culture that it became invisible. We stopped thinking about why we don't eat predators. We just don't, but the evolutionary logic is airtight. Avoiding apex predator meat is not a cultural quirk. It is a survival strategy written into human behavior by natural selection. The groups of early humans who regularly ate apex predator meat got sick more often, accumulated more toxins, died younger, had fewer surviving children. The groups that avoided it thrived. Their behavioral patterns, their food preferences, their cultural taboos, their hunting targets survived. And so did ours. Asterisks off CTA 1000 words asterisk. This is exactly the kind of question that sounds simple until you pull on the thread. If you want more threads pulled, subscribe. We do this every week. Ancient biology, evolutionary science, the questions hiding in plain sight. Hit subscribe and the bell. You won't regret it now. Here's where the story gets genuinely weird. Because we've established why we don't eat most predators: toxins, taste, evolutionary avoidance. But there are some predators that humans have eaten, are eating right now, and the exceptions to the rule are as interesting as the rule itself. Bears. Bear meat has been eaten by humans across multiple cultures for thousands of years. Indigenous peoples across North America and Siberia have hunted and eaten bears regularly. Viking warriors consumed bear meat as part of ritual practice. So why does bear work when lion doesn't? Bears are technically omnivores, not true apex predators. They eat berries, roots, fish, insects, honey, and small mammals. Their diet is varied and sits much lower on the food chain than a pure carnivore. Their muscle composition reflects this. Bears have significantly more intramuscular fat than most true predators, which makes their meat more palatable. Their toxin load is lower because their diet is more varied and doesn't exclusively concentrate compounds from the top of the food chain. Bear meat is still described as strong and gamey. It requires careful preparation, but it sits in a different biological category from a true apex carnivore predator. Fish-eating predators tell a similar story with an interesting twist. Sharks are apex predators. They have all the characteristics we've discussed: high toxin load, high parasite exposure, primarily fast-twitch muscle composition. Shark meat is actually consumed in some parts of the world. Iceland's hackarl, fermented Greenlandic shark, various shark preparations in Asian markets. But notice what every preparation method has in common: fermentation, extended processing, chemical treatment. These methods are specifically designed to break down and neutralize the urea, the trimethylamine oxide, and the other compounds that make fresh shark meat genuinely toxic. You cannot eat a fresh shark safely. You have to process it extensively first. The toxin problem doesn't disappear. It just gets engineered around, which brings us to something fascinating. The fact that humans have found ways to eat some predators, through fermentation, through extended processing, through specific preparation methods, tells us that the avoidance of predator meat is not absolute. It is a risk-benefit calculation, and for most predators in most historical contexts, the risks vastly outweighed the benefits. But here's the most interesting exception of all, one that is sitting in millions of American homes right now, that people feed every day, that people let sleep in their beds and sit on their furniture and lick their faces. Cats. Domestic cats are obligate carnivores, true apex predators in miniature. They eat only meat. They bioaccumulate toxins from their prey. They carry an extraordinarily high parasite load. Toxoplasma gondii, the brain parasite carried by cats, infects an estimated 1/3 of the global human population. They have fast-twitch-dominated muscle composition and almost no intramuscular fat. If you applied every criterion we've discussed to a domestic cat, it would fail every single one of them. You absolutely should not eat a domestic cat, and the interesting thing is, in most cultures you don't. The same biological logic that keeps lions off the menu keeps cats off the menu. The rules apply regardless of size. Now let's talk about why this matters beyond just the dinner table. Because there's a deeper principle operating here that connects predator avoidance to some of the most important patterns in human evolutionary history: humans are extraordinarily flexible eaters. We are omnivores capable of surviving on an enormous range of diets. We have eaten insects, roots, raw meat, fermented foods, marine mammals, and virtually every other food source the natural world has ever offered. Our dietary flexibility is one of the primary reasons we colonized every environment on Earth. There are almost no natural food sources that humans have not consumed somewhere at some point under some circumstances. Almost none. Apex predator meat is one of the genuine exceptions. Not because we couldn't physically eat it in every case, but because across virtually every culture in virtually every environment across hundreds of thousands of years, human beings looked at apex predators and made the same calculation. The risk is too high. The reward is too low. The biology doesn't work in our favor, and that calculation made independently repeatedly across cultures that had no contact with each other tells you something profound. It tells you that the avoidance of predator meat is not a cultural invention. It is a biological truth that different human populations discovered independently and encoded into their food practices, their taboos, their hunting strategies, and their cultural norms. The convergent avoidance of predator meat across human cultures is itself evidence of the biological logic underlying it. When people who have never met each other and share no cultural history all arrive at the same conclusion about what not to eat, the conclusion is almost certainly correct. Soft CTA 1500 words *. Every video on this channel starts with a question that seems simple and ends somewhere completely unexpected. If that's the kind of content you want in your life, subscribe. It genuinely helps the channel, and it means you'll never miss one of these. But here's the final piece of this puzzle, the one that brings everything together, the one that connects predator avoidance to the deep structure of how ecosystems actually work. Apex predators are not supposed to be eaten, not by us, not by anything. That is the entire point of being an apex predator. The food chain is not just a description of who eats whom. It is a functional system, a biological machine in which every component plays a role. And the role of apex predators is specifically to sit at the top of that machine, to regulate the populations below them, to shape the behavior of prey animals in ways that cascade down through the entire ecosystem. When apex predator populations decline, whether from hunting pressure, habitat loss, or any other cause, the effects ripple through every layer of the ecosystem below them in ways that are often catastrophic and extremely difficult to reverse. The reason you can't eat predators isn't just biological, it's ecological. Predators are too expensive to consume, not in money, in ecosystem function. The energy required to produce a pound of predator flesh in terms of food chain length, in terms of habitat, in terms of prey consumed, is orders of magnitude greater than the energy required to produce a pound of prey animal flesh. Eating a predator is, from a pure energy efficiency standpoint, one of the most wasteful things you could do. You are consuming something that took an enormous amount of ecosystem resources to produce, something that was performing a function in that ecosystem that nothing else can easily replace, something that once removed leaves a hole that the entire ecosystem around it will struggle to fill. Human food cultures almost universally arrived at the conclusion that predators were not food. Not through conscious ecological reasoning, not through an understanding of trophic cascades or keystone species or any of the concepts that modern ecology uses to explain these dynamics, but through experience, through trial and error, through generations of observing what happened to the animals and the landscape when certain species disappeared, through an accumulated practical wisdom about which animals could be harvested safely and which ones should be left alone. That wisdom, encoded in food taboos, in cultural practices and religious frameworks, in hunting traditions across every human culture on Earth, turns out to be ecologically correct in ways that modern science is only now able to fully explain. Your ancient ancestors didn't know what a trophic cascade was, but they knew on some level that the lions needed to stay, and they built their food cultures around that knowledge without ever being able to articulate why. So the next time you sit down to eat chicken, beef, lamb, fish, think about what's not on the table. Think about the lions and the wolves and the eagles and the sharks that are conspicuously absent from every menu you have ever read. Their absence is not an accident. It is not a gap in human culinary creativity. It is the result of millions of years of biological logic, thousands of years of cultural wisdom, and a convergent conclusion reached independently by virtually every human population that has ever existed on Earth. Some animals are food. Some animals are the reason food exists at all. And your ancestors, without a biology degree, without an ecology textbook, without any of the scientific frameworks that modern humans use to explain these things, figured out which was which. And passed that knowledge down to you in the form of the most powerful cultural force in human history, what you will not eat, and why.